and support people, I'm going to show you some things I saw. Number 2, like when I looked at Carla's paper, she had x equals negative 16 plus y cubed. And then when we start step 3, we begin isolating y. So this is where I need to undo everything that's going on right here. And what I was trying to tell folks, you want to make sure you work from the outside in, okay? What's furthest away from the y is what you need to get rid of first. And that negative 16 is farther away than the power of 3. So how do I cancel a negative 16, Alejandro? You add 16. This is what I saw overwhelmingly on lots of papers. So I've got x plus 16, or maybe you wrote 16 plus x, same thing, equals y cubed. And here's where I had the most questions. Miss. Hey, Miss. How do I cancel a cube? For some reason, when I have a square on a problem, y'all are fine with that. Because you learned that squares cancel with square roots. Cubes cancel with
cube root.
Same radical, but I have an index of a 3 on it. That's how we cancel. So I'm going to do that to both sides. These are gone, and I have y equals the cube root of x plus 16. Step 4 is to replace y with f inverse. So we have f inverse of x equals the cube root of x plus 16. And step 5, domain and range. Gotta be careful. Oh, I'm doing it all the numbers. Domain and range. Some of you get yourself a little worked up here for no reason. When we learned about domain a few weeks ago, I told you that with rational functions, there's one number you can never divide by. What number is that?
0.
0. And with radicals, and I probably said it wrong, I have a feeling I said, with radicals you can only take the square roots of positive numbers. This, however, is not a square root. It's a cube root. And square roots and cube roots do not behave the same way. We're going to get into this way more next unit. But if I take the square root of 16, I get an answer of 4. Well, technically plus or minus 4, but whatever. And when I take the square root of negative 16, 4i in pre-cal, that doesn't exist. Okay? Can't square root negative number. However, let's talk about this. What's the cube root of 27? Not 9.
3.
3. Because 3 times 3 times 3, 3 3s, multiplied together get me 27. And what's the cube root of negative 27? Negative 3, not D and E. Because negative 3 times negative 3 is 9. Times negative 3 is negative 27. So it turns out it's actually legal to take the cube root of negative numbers. It's illegal to take the square root of negative numbers. Moral of this story is, since there's a cube root here, I don't need to take x plus 16 and make that positive. I can have positives and negatives under there. And back here, I didn't have any restrictions, right? It was just all real numbers for both. And what I told you is, with inverse, domain, and range, you can just switch them up. So some of you didn't even think about it. You just switched them up, which is awesome. But if you fall into my trap and you think about it too much, you might do more work than you need to. So I just want you to switch things up. Deep breath. When I think about that problem that you just did on a rigor scale from 1 to 10, I'd call that one like a 4. 3 or 4. And the one we're about to do, I'd call like a 9. Rut row, is that what you said?
Yeah.
That's funny. Okay, go back to 75. Notice I left us a whole page for this one, because this one's real. Is that 75?
76.
76. I can't count. I'm sorry. That's the problem. I can't count. Okay, the function is x minus 1 over x plus 2. Your task right now, please open a calculator. If you do not have one, keep on with a neighbor. Open a calculator and get me a picture of this. Draw a rough sketch. Timer of 1 minute. Somebody 1 minute. Give me an update on your calculator. Oh, give me an update on your calculator. I need a letter. Did you write it? You said that should bring me a letter.
There, did you get it? I got it. Sort of. With like they're closed, but I don't know if like I don't know. Oh, that's hard to find the inverse, because then you're gonna have to do like
Okay, sorry. Deja, beautiful picture. Okay, sorry. I'll come back. My bad. Is the function that you guys see continuous? Yes or no, and why? Hands. You can use teenager language to answer this question. You don't need to use mathematical language. Adriana.
Yes, because in the horizontal line test, it only passes through 1 because of the asymptote separating them.
Okay, careful here. That is why the function is 1-to-1. My question, is the function continuous? Yes, no, why? Jeanette?
no, because you gotta pick up your pencil to do the other one.
Gotta pick up your pencil to draw both pieces. But she's ahead of me. We're gonna get to her response in a minute. I just wanted to remind you of continuity. This is not continuous, have to pick up my pencil. And I believe based on the sketches that I'm seeing, it looks something like this maybe, and then maybe like that. Yay? Yes, no, maybe so?
Mm-hmm.
And as Abrielle mentioned, okay, so first of all, discontinuous. Have to pick up my pencil to draw this thing. And step 1, though, is the function 1-to-1. Absolutely. F of x is 1-to-1. We passed the horizontal line test. No matter where I put that line, I'm only going to hit the function 1 time because of the asymptote. I love the language that she used. Bless you. So as soon as I get a check mark, as soon as I get a check mark there, I know I need a domain and I need a range. And this is a scenario that's worth reviewing. F of x is x minus 1 over x plus 2. We've talked now for several days about that one number we can never divide by. That number is 0. Many of you, by inspection, can look at this denominator and intuitively determine what number would produce a 0 in the bottom. Many of you can just look at that and tell me -2, because -2 and 2 make 0. If that's not a natural thing for you, our safe strategy is to take the denominator and set that equal to 0. When I solve, I move the 2, and I get that answer that some people can gather by inspection, -2. This means I come way over here, and I tell the reader that the domain is all real numbers except x equals -2. I only use the structure all real numbers except